I bought 4 broken PS3 to see if I can fix them all. First, let's try to turn them on one by one. So far, all of them seem to have the notorious yellow light of death problem. Surprisingly, the last one stays on green light. Let's call it console number 1 and see what's wrong with it. Let's connect it to a monitor to see if we can turn it on. Nothing is showing on the screen. I think it is having a green light of death. Let's take it apart to see what's wrong inside. Heating up the warranty sticker helps softening the glue, which makes the sticker removal process much easier. After removing the sticker, the surface is not even sticky. We don't need to clean it. Now, let's remove our first screw hidden inside this little plastic. The screw inside is tamper-proof. We need a special screwdriver bit to remove it. We can remove the cover now, and then remove all 7 screws you see here. Because it is a CE-CHB model, it has 7 screws instead of 9 screws as in CE-CHA models. Unplug the power connector on the motherboard and remove the power supply. Now let's remove the Blu-ray drive. Again, unplug the power connector on the motherboard, but don't pull up the drive yet because there's a cable below it. Unclip the connector and remove the cable. Now we can safely remove the drive. Now let's remove the Bluetooth module. And then remove the power button module. Remove all remaining ribbon cables you see on the motherboard. And remove all the screws you see here. Before removing the motherboard, we need to remove the hard disk. I always like to remove the motherboard using gravity, like this. Then unclip the back panel. Remove the brackets for the CPU and the GPU. We can remove the top metallic shield now. You can already start extracting the syscon errors at this point, but in case you want to further tear it down, I'm going to show you how. Usually, the fan is stuck to the CPU and GPU, but we can heat it up a little bit and remove it easily. You need to be careful when removing the CMOS battery. Do not pull up the yellow connector on the motherboard. Finally, remove the last 2 screws. Now, it's time for us to extract the syscon error log. We need to attach 3 cables into these 3 pads. Let's apply some flux to make the soldering easier. I add some low melt solder to lower the melting point. Now it's time for us to apply the 3 jumper wires. To extract the syscon errors, we need to apply 5 volts to the motherboard. We can simply use the original power supply to supply 5 volts voltage to the motherboard. There is no need to turn on the console, we just need it to be in the standby mode. Let's attach the power button back to the motherboard, so that we can check the LED indicator. Now we need to attach the jumper wires to our TTL. The yellow one should go to the TX pin of the TTL. And the red one should go to the RX. Depending on your TTL, there should be a label on each pin. We do need to connect the DIAG pad at the moment. Finally, we need to ground our TTL. Connect a 4th jumper wire from the ground pin to the ground plane of the motherboard. At this point, we don't need to connect the DIAG pad to anything. Now connect the TTL to your computer. Remember, ground the TTL but don't connect anything to the DIAG pad. On your computer, check which COM port is the TTL using. In my case, the TTL is using COM 4. Remember this number, we will need to use it later. I'm using Anaconda to install all the libraries required to get access to the syscon error log. I first activate the virtual environment. Then I go inside the folder containing the Python script for syscon. You can download the Python script online. I will put a link in the description below. We can get access to the syscon using this command. Enter the COM port that the TTL is connected to. And then we try to authenticate ourselves. Once we are inside, we can extract the errors using this command. But each time it only returns one error, which is very inconvenient. To get all the errors at once, we need to enter the internal mode. There is a tutorial online about how to get access to the external and internal mode. I will put the link in the description below. Basically, we just need to modify the value at the address 3961 to 00 using this command. After that, turn off the power and turn it on again. You will hear 3 beeps, but don't worry, because we forcefully modify some values and the console is telling us something is wrong. To tell the console everything is okay, we need to go back to the syscon. But this time, instead of CXR, we use CXRF. Oops, it says authentication failed. We forgot to ground the DIAG pad. When entering the internal mode, we need to also ground the DIAG pad. Let's do it now. Turn off the power and turn it on again. Go back to the PC and try to log into the syscon again using the internal mode. We need to change the checksum so that it matches with the value that we modified. This command should tell you what's wrong with the checksum. This line here tells you the correct value at address 39FE should be 0F38. We can modify the value of that address using this command. After the modification, double check everything is correct. If everything is correct, you won't be able to see this line anymore. Otherwise, something is wrong. Okay, I found my mistake. I mistyped the 0F into 00. Let's put the correct value back this time. And then double check the checksum. Now everything is okay. Turn off the power and turn it on again. If everything is correct, you won't hear the 3 beeps anymore. Go back to the syscon and authenticate yourself. This time, we can use this command to extract all the errors. According to the error history, this console is having bad NEC tokens. But it seems the original owner managed to turn on this console for a few more times until it has the BGA problems. The error code 3034 implies that there is something wrong with the RSX GPU, which explains the green light of death of this console. To fix this console, we need to replace both the capacitors and reboot the RSX GPU. Unfortunately, my rebooting skill is still not good enough as shown in my latest video. I will keep this console until I improve my rebooting skill. Now let's move on to the second console. Let's take it apart quickly. Syscon error log indicates that this console is having bad NEC tokens. Let's replace the capacitors for both the CPU and GPU. First, we need to remove the original NEC tokens. Personally, I like to remove the plastic case of it first. And then I use a blade to remove the layers from the capacitors. Remove as many layers as you can. It makes our job easier later. This is a close-up on how to remove the remaining layers. The last layer is soldered on the motherboard. Let's apply some flux and desolder it from the motherboard. I use 400 degrees Celsius for my soldering iron and 250 degrees Celsius for my hot air. According to my experience, each token consists of 3 different parts: the top positive terminal, the bottom positive terminal, and the ground plane. Let's desolder them one by one. The first positive terminal is removed successfully. And the bottom positive terminal is also removed. Now let's remove the negative terminal. The key is to heat up these 2 areas. When it reaches the melting point, you should be able to remove it easily. Do the same thing to the remaining tokens. After removing all the tokens, time to clean up the pads. It is a little bit challenging to clean up the pad like this, because the PS3 motherboard dissipates heat quickly. When the temperature decreases and the lead solder solidifies, the desoldering copper gets stuck on the motherboard. The size of the replacement capacitor is a little bit different from the original capacitor, so we need to make the ground plane larger. I like to use this method to solder the new capacitors back to the motherboard. Put a small amount of solder on the pads of the capacitors. Then put the capacitor back to the right position. After that, use the soldering iron to touch the pads of the capacitors. The solder should melt immediately and attach to the motherboard. Do the same for the remaining capacitors. I only remove the tokens from one side of the motherboard. I keep the token on the other side so that it acts as the bridge between the two positive terminals. Now let's test the PS3 to see if it works. I only put it back barely enough to test it. Yes, it works. This console is from Japan, so everything is in Japanese. Let's see, what games does the original owner play? I see BioShock, Metal Gear Solid, and Dark Souls. Enough testing. Let's see if we can fix console number 3. Syscon errors show that this console is having both bad NEC tokens and bad BGA. To fix this console, we need to replace the capacitors and then do a rebore. Replacing only the capacitors would not fix this console. Finally, let's have a look at console number 4. It seems we also need to do a rebuild on this console. In the end, we managed to fix only one console by replacing the capacitors. But if we can do a rebuild successfully, we should be able to fix the remaining 3 consoles. Here are the conclusions. According to Syscon, 75% of the console have bad NEC tokens. And also 75% of the consoles have BGA problems. The number does not add up to 100% because 50% of the consoles have both problems at the same time. Nonetheless, the take-home message is you should always check the Syscon errors before fixing the consoles. This pie chart shows the reasons of failure for the 4 consoles that I bought in this video. I know 4 consoles is a super small sample size to represent anything meaningful, but I hope this information is still useful for someone out there. Thanks for watching. If you want me to make more videos like this, leave a like and subscribe. See you next time.